Coming up, we build an engine-sized puzzle, squishy sounds, and a bit of stretching.
Gentlemen and 3 ladies that are watching, welcome to Project Frankfurt, the E92 M3, a complete engine rebuild. Don't ask me how long it took to arrange this.
Laying in front of you on this giant carbon fiber towel is the entirety of one of the most amazing creations spawned by BMW Motorsport division in the mid-2000s. The naturally aspirated 8400 screaming RPMs out of this 4-liter V8 engine codenamed S65B40. And in this video, we are going to assemble it completely, bolt by bolt, together.
Okay, can one of the board members help me lift this, please? And now you're getting up. Focus on the cocaine, it's fine. I think Mutzi would love this blanket. We are kicking off with piston oil spraying nozzles, aka piston squirters. I've thoroughly cleaned the block once again and used compressed air to blow out all of the oil passages. I'm applying a little bit of medium thread locker on the screws. These are M5 8.8 grade screws and the torque for them is 6 Nm. The following step is to reinstall the clean crankshaft. Then we have the bed plate and main bearing bolts. TIS, the repair manual, specifically says not to use brand new bolts, presumably because these have been stretched by the robot in the factory, so you don't have to do it again. For the main bearings, we're going with King Race bearings. This is their PMAX Black series. So first, we're going to install everything dry, use the plastic gauge to check the clearance, disassemble everything, get the reading, and if everything is okay, then we can do the final installation with the assembly lube. Cleanliness is of the utmost importance here. I made sure that the residence of the main bearings is clean, and now we can pop them in. There is a notch on the bearing that we need to line up with the cutout in the block. And just push it in and make sure it's seated correctly. And now we can gingerly pop the crankshaft in very carefully. And now the bed plate. The bed plate here we can use a very fine Scotch-Brite and a bit of brake cleaner to clean the seating position of the bearings, remove the old bearing material. Clean it well. Now discard the gloves. Make sure to push the bearing all the way in. Now you're going to apply a bit of silicone spray on the bearings. That way the plastic gauge doesn't stick to it. If you put it in dry, it's going to be a bit difficult to remove the plastic gauge after and not damage the coating on the bearings. And this won't affect the measurement at all. Get the plastic gauge in place. Okay, that's the plastic gauge in place. Careful with the bed plate. It's heavy. The repair manual says that the threads must be clean and oiled, so I'm going to use fogging oil for men. First, the fitting M9 screw in position number 1 and position number 2. The torque spec is 8 Nm. And now we can pop in the rest of them. And now torque the rest of them to 8 Nm in 1:8 sequence. And now the M11 main bolts. We can use the electric ratchet to slowly drive them in. The torque is 30 Nm and we are going in 1:10 sequence. I should also mention that I had my Hazard torque wrenches recalibrated by Hazard recently and they're all within spec. Now we need to apply a paint mark on the M11 bolts. And now we're going to torque them 130 degrees in 1:10 sequence. And now the M9 fitting screws are torqued to 15 Nm. Again, we need to apply a straight line on the bolts. These bolts are now also torqued 130 degrees. And now the smaller main bearing bolts, also lubed up with oil. And now we have 4 bolts here. These are middle length and 2 short ones in the front. Drive them in. This is T45. Start them by hand always first. The torque for these bolts is 5 Nm and then 90-degree angle, but there is no specific torque sequence in the repair manual, so I'm just going to start from inside to out. And now 90-degree angle. Okay. Smaller ones are torqued to 5 Nm and then 60-degree angle. Beautiful. And then the 2 front ones are torqued to 15 Nm. And that's it. That's the entire procedure. Now we need to release all of the screws in a specific sequence. So we're starting with the M9 fitting screws from 1 to 10. And now the M11 bolts, also from 1 to 10. They all look exactly the same, which is good. The bearing clearance should be from 0.0305 to 0.0508 millimeters. I've explained this in the past. The plastic gauge is not going to give us a precise measurement, but it will tell us if we are within spec. So 0.038 is wider and 0.050 is narrower, which means that we are somewhere between those 2 specs and that we are well within spec because the rest of them are exactly the same and we are safe to proceed and use King Grace bearings. Quite happy with that. To remove the plastic gauge, use brake cleaner and a clean carbon fiber towel. Remove the crankshaft. Now I need to make sure that the sealing surface in this channel is perfectly clean. I already cleaned it, but I'm going to do it once more for good measure. Brand new gasket. Assembly lube and a clean finger. Crankshaft going back in for the final time. You can see that it spins. Say on a more traditional engine, we would have individual main bearing caps here, and then a standard metal / rubber gasket will come around to seal the upper oil pan. But this is bed plate design, which is essentially one-piece block that's chopped in the factory. So you have the block and the bed plate that comes on the top. This means that there is no standard gasket that goes around. Instead, we first need to install the bed plate, torque it down fully, then install the front and rear crank seals, and then inject special sealant / glue thingy from Loctite through these ports on the sides. And that's what's going to fill this channel here and create a permanent seal between the bed plate and the block. Okay? Good. The bed plate, we need to make sure this is thoroughly clean, otherwise it will not seal correctly, and if it doesn't seal, you need to remove the engine out of the car and repeat this entire process. You only get one shot at this. The exact same installation process as before. First, fitting M9 screws in position 1 and 2. Make sure you're using a clean socket. I use this thing for everything, so it's likely full of sand, dirt, and cheese. So clean it, otherwise you can contaminate the engine and transfer that dirt from the socket to this bolt. Draw a line. Here you can see the lines that I made earlier and that they match and that everything is torqued correctly to spec. And now the crankshaft must turn smoothly without any resistance, which it does. And that's the crankshaft reinstallation done. Next up, the front and rear main seal, the gear for the oil pump drive, and the timing chain kit. This is the kit that was sent to me by Ivis or Evis, and this is the OE part. In other words, the exact same part you get when you buy it directly from the dealer. And if you don't believe me, here's a direct comparison between the old original part that came out of this engine and the new one. You can see that it says on there Evis, so no difference whatsoever, except this is a lot cheaper when you buy it from them versus the dealer. They have timing chain kits for various engines like N62, M73 and so on. Link is in the description, so feel free to check them out. First, the timing chains. Then the gear wheel. There's a pin that you need to line up with a hole in the crank. There it is. As you would imagine, there is a special tool to install the seal, which you've guessed it, I don't have, so we're going to improvise. Be very careful here. The seal is very sensitive, so first I'm going to put it from the back side of the intermediate piece. Slide it on like that. And I'll go to SmackDown. It's starting to go in. All right, the key is to tap this evenly. Gonna use this long threaded rod. And then put this cup here and slowly drive it in. Should work, just like the original tool. What is that? It's Alpina! What do you want? The B10 is complaining for some reason. Okay, I shushed the Alpina. So this one is going to serve as a guide. Yeah. So this seal needs to sit flush with the inner lip, not the outer one. Now we can install this screw fully. This is an M6 screw and the torque spec is 10 Nm. Now I can measure all around and make sure that the seal is seated properly. Beautiful. And that's the front crank seal installed. To do the rear main seal, I need to take the engine off the stand, which is tricky at this point because this is quite heavy. Let's see how we're gonna do that. Ideally, I want to put it on the table, but I don't know if I can. All right, I'm gonna break my back and you watch. Oh my God. That is quite heavy, dude. Okay, I put the block on the table. Be very careful not to damage the seal. Did I mention that you're supposed to have a special tool to install this? In case it wasn't obvious. I'm gonna grab the old seal and use that. So this one needs to sit flush with the inner lip as well. That's the seal, wonderfully installed. Have to put the pilot bearing here a bit later for the manual gearbox. While we're here, we can do the screw plug for the main oil gallery, the plug with a brand new washer, okay. This is the sealing compound for the bed plate. You can see it says Filangi sealant. This is the primer. This is the tool used to press in the sealant into the bed plate, and that's the part number for it. Injection ports, and this is the injection nozzle that comes with the kit. It's way too thin. Throw it away and get something like this. This is a bit wider. A friend sent me this, but you can easily get this on eBay or Amazon. Now we need to tap in the injection port. Once we start injecting the sealant and the channels are full, it'll start oozing out through these two vent holes here. Same on the back for the rear main seal. Then we need to use the primer, which is going to harden the sealant because this particular sealant is anaerobic, which means it cures in absence of air. So that means we need to seal it here, here, on the back and the injection ports, and then it's going to cure within the channel. Per Loctite instructions, we are going to apply a bit of primer now here. And then on the back as well. Never done this before, so let's see how it goes. All right, it's coming out. Okay, so let's start injecting. So you gotta do this slowly. Nope, this is just coming out on the outside. So I'm gonna ditch this and try without the injection nozzle. Whoa! It's coming out here. So stop, and let's get the primer. Oh, it's starting to come out on the back as well. So I'm gonna start injecting a little bit more, just a tiny bit more. Okay, it's coming out on the back as well. Apply primer there as well. This better works. Apply it on the ejection port here. Now we gotta do the other side and hope that I have enough sealant left in the tube. So yeah, don't use the injection nozzles, just put this directly onto the injection port and start injecting. Oh, there it is. It's coming out on the front. How about the back? And the back as well. Fantastic. You see it oozing out. Primer. And that's done. This wasn't too bad. Says he, hoping this actually worked, because if it didn't, I'm gonna have to take this engine apart again. Moving on with the bottom end, we have Mahle Motorsport higher compression forged pistons that come with new wrist pins, piston rings, and circlips. Then stock connecting rods, there's nothing wrong with them, and this engine is going to remain NA, naturally aspirated. And then for the rod bearings, we have BE bearings and ARP rod bolts. BE bearings are, in my opinion, the best rod bearings you can get for the S65 and S85 engines. That's what I have in Project Raleigh, my E60 M5 for the last 30,000 kilometers. Number one, they're made by Clevite, Mahle, which is the same manufacturer that makes original rod bearings, so you know that the quality is on point. Number two, and this is the most important part, they're made to a custom BE bearing specification, and they offer more clearance compared to the stock ones that offer too little clearance, which is leading to premature bearing wear and eventually to an engine failure. One of the reasons why these engines suffer from rod bearing failures. Number three, each bearing is individually measured by hand by BE bearings and then sorted lower and top. The only bearings on the market that are manually sorted like that. And if you're just doing the rod bearing service and the crank is in good condition, you don't even have to plastic gauge them. You can just plop them in and torque the rod bolts to spec. And number four, this is their latest version 2 that's part of the new F bearing design that now has silver oxide coating and can handle 30% more load than before. We're going to start by prepping the connecting rods. These are fracture split connecting rods, and each connecting rod and the rod cap are stamped on the side because they're unique. You can't mix and match here, so make sure to pay attention to that. Grab a fine Scotch-Brite, bit of brake cleaner, and clean the bearing seating surface. This will remove all the bearing material, and it's important to do this. Now I'm going to go rinse this out with brake cleaner and blow it out with compressed air, and repeat this with the rest of them. Before we proceed, it's important to learn how cylinders are numbered and which bank is which. Looking from the front of the engine, the left side, that's bank 1, and this is bank 2. Cylinders 1 to 4, cylinders 5 to 8. The orientation of how the pistons and connecting rods are installed and connected is very important. The pistons have an arrow on them, and this arrow points towards the front of the engine. I put an additional one so it's easier to see. This is bank 2, bank 1, and the connecting rods on bank 2, these two notches here need to point up, and the piston connects like that with the wrist pin. And on bank 1, those two notches are on the back, and the piston connects like that. The installation of the circlip for the wrist pin is a bit tricky if you don't have the correct tools, and I don't. So I'm going to use this plastic wedge and my fingers and plop it in. So basically you want to start one end in the groove and then just keep pushing the circlip. And it is also very important to wear eye protection here, because if this thing pops out, it will take your eye out. There it is. And if you make a scratch here, it does not matter. This is dry phosphate film, and it's just for the first startup of the car. So don't worry about that. I just looked up Mahle Motorsport instructions regarding this. Clean the wrist pin, lube it up, the piston as well, and the connecting rod. This must slide freely and move freely as well. The second circlip. There it is. Just need to repeat this process with the rest of the pistons. And this is how the orientation looks like from this angle. Bank 1, the arrow goes towards the front of the engine, and the two notches are facing towards the rear of the engine. Bank 2, arrow goes towards the front of the engine, as well as the two notches. Now we're going to check the piston ring gap. Lube up the top of the cylinder, grab the first piston ring, lube it up as well, and gently pop it in. Now grab the piston and push in the piston ring evenly 25 millimeters into the cylinder. I made a mark on the piston here. So you can see here it's sitting flush. This is 0.20, fits easily. 0.25 fits as well, and 0.30 does not fit. So the gap is 0.25 millimeters, and that's within spec. Take it out. Now grab the second one The gap for the second one is between 0.40 to 0.60 millimeters. Here's 0.45, fits in easily. 0.50, fits easily. 0.55, fits snugly. And then 0.60 does not fit. That's within spec as well. And don't worry if the piston ring leaves marks on the cylinders. That's unavoidable when working with Aluseal, does not affect anything. The gap for the third piston ring is from 0.01 to 0.03 millimeters, but it is a 3-piece oil ring, so you can't really measure the gap. Anyway, that's the process. I'm gonna continue and check the piston ring gap on all of the cylinders. I finished checking the piston ring gap and it's all within spec. Now it's time to install the piston rings onto the pistons. First thing to note, there is a top and bottom side to the piston rings. You can see it very nicely explained here by Mahle Motorsport. The second ring has a dot here that goes towards the top of the piston, and the first ring has some markings here that goes towards the top of the piston as well. And for the third piston ring, it's very important to install it correctly, like that and not like that. The two ends need to touch each other and not overlap. Lastly, the piston ring gap alignment. We need to spread out the gaps so that they're 120 degrees from each other. The third bottom oil ring, it's a 3-piece, and the expander, that's the bit that sits in the middle. The gap should be pointing that way, and then you have the bottom and top rail gap. Then you have the second ring gap pointing that way and the first one that way. In any case, the gap should not be over the wrist pin, and once the engine is up and running, the piston rings move, they float, they don't stay in the same place. Let's begin. First, the bottom oil ring. This is the expander, which we need to cover in oil and then gently put it in place. The gap is going that way. Very good. Then the rail, also smear it with oil. So this can be the bottom one. Okay, that gap is going over there. You can take a thin screwdriver and just move it. And then the top rail. The gap sits right about here. And then for the second and first ring, we are using this special tool to safely open up the ring and slide it over the piston into the groove. Lube it up. Again, pay attention to the orientation. This dot must point up. The gap should point this way. And this gap should be positioned there. And that's the piston rings installed. Rinse and repeat with the rest of them. Make sure piston rings move without any resistance. Brilliant. And that's the piston ring installation done. Time to install the rod bearings. Make sure that this is clean and free of oil. The lower one goes into the rod cap and the top one goes into the rod. Same as with the main bearings, so line up the notch with the cutout in the cap and then push it in, making sure it's sitting flush. Like that. And these marks here, that's from the measuring tool that BE Bearing is using, and nothing to worry about. And continue this process with the rest of them. That's the rod bearings done. Rod bolts. These are BE Bearings ARP bolts, not a standard ARP bolts, also made to BE Bearing specification. And this is the fastener assembly lube from ARP. We are applying the lube on the threads of the bolt. And then underneath of the head of the bolt. I'm just going to do the same with the rest of them. Now throw away the gloves. Do not transfer this over to the rod bearings. Now I can start planting the pistons. Apply more oil on the wrist pin. And then of course, more oil onto the piston rings. and the piston skirts. So make sure once again that the gaps are turned correctly. Also a bit of fogging oil from men to seep through absolutely everywhere. Piston compression tool, oil it up as well. Pop it over and then tighten it. Now tap it until the skirts are exposed. Like that. And the assembly lube will come later. First we need to check the clearance with Plastigauge. What I also like to do, and this is just an extra precaution, is put masking tape on the corners of the connecting rods here. That way we don't risk leaving marks and scratches in the cylinder. And that's ready to be installed. Lube up the cylinder with clean gloves, of course. The air on the piston points towards the front of the engine. And we can slowly insert it. Make sure that the crank is as far away as possible from the cylinder and start tapping. It's one in. Now I need to flip over the block. Now you can remove the masking tape. The crankshaft is clean and now we can carefully pull up the rod. Be very careful not to scratch the crank. That's it. And when turning the engine over, be very careful where the connecting rod is and in which direction you're turning the engine on the engine stand, because if you do it the opposite way, the connecting rod can actually smack the crank. And that would be extremely bad. So either hold it with your hand or make sure you're rotating in the correct direction where the connecting rod cannot move and hit the crank. Plastigauge. Make sure to match the number that's stamped on the cap and the connecting rod. In this case, it's 831. Apply silicone spray on the rod bearing. The torque speculation for ARP rod bolts is 68 Nm or 50 pounds. Now you can release the bolts. That looks identical. The nominal rod bearing clearance for the stock rod bearings is 0.0381 millimeters, and for the BE bearings, nominal rod bearing clearance is 0.0681 millimeters. And here, if we first try 0.050, no, more clearance than that, 0.063, that's pretty much bang on the money. Definitely not as high as 0.076. And then this one is exactly the same. Again, we can't get a precise measurement with Plastigauge. It'll just tell us that we are pretty much in the ballpark, and BE bearings is saying 0.068, and here we are getting around 0.063. So that is bang on the money. So exactly as BE bearings is claiming, more clearance than stock, which means that more oil can flow around the crankshaft, which is especially important with 10W60 oil, which is as thick as it gets. Now lower the connecting rod so we can apply assembly lube. Remove the Plastigauge. A very clean finger, assembly lube, and lube it up. We can clean the bearing with a clean carbon fiber towel and some oil. Bit of Foggylicious oil for men for the crankshaft. Assembly lube applied on the lower bearing as well. And again, match the numbers on the side. Rod bolts. Don't use an impact here, always start engine bolts by hand, for that matter, any bolts. Dump a bit more oil into the cylinders. And now we can turn over the rotisserie chicken and it should spin smoothly without any resistance. Which it does. Beautiful piston dance. The rotisserie chicken is ready. Look at the pistons going up and down. And with that, the bottom end is assembled. Let me have a quick breakfast of amateurs and then we'll proceed. I did plastic gauge all of the rod journals and the clearances from 0.050 to 0.063 millimeters. So all within spec and good to go. Coolant drain plugs, one on each side. Brand new crush washer. Before we proceed with the cylinder head, first we need to pop in a couple of parts here. Here lives a non-return valve on both banks. Here's a brand new one. I've covered it in oil. And then a spacer. Then we have new dowels here and here. Two screw plugs here on both banks. Here's a brand new one with Loctite applied. And these don't have a specific torque. They seal with Loctite. So just thread them on. Okay, because this Loctite is coming off, I'm gonna remove this screw plug, remove that Loctite all the way, and apply my own. Thread sealer applied. And copy paste on bank 2. And here we have a non-return valve for the CCV, crankcase ventilation, which we can also install later, but I found the part, so we're gonna do it now. Brand new one, and make sure to lube up the O-ring. A screw. Gonna put a piece of tape over it and close it off. This clip for the wiring harness goes here. We can do this later, but why not do it now? Because I already have it. Brand new timing chain guides. I put fresh O-rings on the bolts here, and we also have brand new plugs. Lubed up O-rings, and this bolt needs to slide through the guide and into the block. Now I can grab the chain. Beautiful. For this bolt here, we're using a special tool from the timing tool kit. Fish out the chain. And then the central bolt goes through both of these guides. First, do it one by one. This one here. There it is. New plugs. Brand new OE head gaskets. Clean the surface.
These are the cylinder heads from the original engine that exploded spectacularly and now have been overhauled completely by Topmar Motorworks from Poland. They have done a tremendous job bringing these heads back to life, and their work didn't include only the standard valve job, but also a multi-angle valve job and modifying valves to high flow, and now exhaust and intake valves have an additional 30-degree angle. They didn't stop there though. S65 heads have ported intake channels from the factory, but exhaust channels aren't. They polished the intake channels, retaining the original structure, and ported the exhaust side. Here you can see a pretty significant difference in what they managed to achieve with the exhaust ports. From the factory, these channels are only half machined, and normally there should be a smooth transition here, but we have over a 1mm peak here, and Lucas thinks this might contribute to the famous discrepancy in power of the E90 M3 models and why some make less power than what factory claimed. I'm thrilled with the results and happy to be working with a company that enjoys their work as much as I do. And to quote Lucas, these heads will work like crazy. Also, I installed Schrick upgraded springs and titanium retainers in preparation for Schrick cams.
Let's see if I can zip tie this somehow out of the way. Think that'll work. Do the last round of fogging oil for men. Bank one cylinder head. Brand new head bolts. The torque spec for the head bolts is 40 Newton meters and then 90-degree angle twice, and we are torquing from inside to out in a 1 to 10 sequence. Fortunately, I don't have a lot of metal here where I can put my magnet. It's all aluminum. Gonna bolt down the steel plate here just so I have a place where to hook my magnet to. Let's see. That'll work. 90-degree angle. That's the first round done. Second round. Done. Bye-bye cylinders. Bye-bye. And pistons. Hopefully I don't see you ever again. Smooth. I don't know if I mentioned it before, but the head bolts are lubed up with oil per the repair manual, and they also come brand new, slightly coated with oil. Number one. Round one done. Finito. Then we have two small M6 screws in the front on both sides. A bolt for the timing chain guide. And another one here. We have 4 check valves in the cylinder heads, 2 per bank. Here it is with a brand new O-ring. Couldn't find a torque spec for this, so just make it snug. And then on the sides here, hydraulic lifters, which I've cleaned, and now we're gonna dump them into some fresh oil and install them. But fun fact, I checked with the dealer and these are completely out of stock. You can't buy them brand new anymore. Not sure what's going on and if they're going to restock them, but thankfully the old ones are in perfect condition and we are good to reuse them. Oil. Fogging oil for men. The camshafts, these are the stock camshafts from the original blown up engine, and they're in perfect condition. My plan was, and it still is, to go with Schrick cams, but they're currently out of stock everywhere. Schrick told me the next production run is in November, which is right now. So hopefully they arrive soon and we can install them at a later date. For now, we're going with the stock ones. You can't mix and match here. Every cap and every cam is labeled from the factory. You can see here it says A1, E1, 1 stands for Bank 1, here it says 2, Bank 2. A stands for Auslass in German, which is outlet, and then E stands for Einlass, inlet in Deutsch. So as we would say in Germany, vamonos! First we're going to set the engine 10 degrees before TDC. This here is top dead center, and this is 10 degrees before top dead center. Cover the cam in fogging oil for men. Pop the cam in. Per the repair manual, the lobes on cylinder number 1 and 3 need to point upwards at an angle like this. The locks here need to be locked and point upwards like that. More oil. Now we can get the caps on. E1 goes in cylinder number 1 and air is pointing towards the front of the engine. Then E2. Slowly do them up in a crisscross pattern. With the exhaust cam, the lobes on cylinder number 4 need to point upwards, like that. A, E, also 13 millimeters. And it's copy paste on the other side. Bank 2 intake cam. Lobes on cylinder number 6 must point up. Bank 2 exhaust cam, the lobes on cylinder number 5 need to point upwards. And that's the camshafts installed. Time to install the Vanos units and time the engine. These are the Vanos units from the donor engine, brand new Vanos bolts, timing chain tensioners from Ivis, and upgraded Vanos cups. This is the stock plastic cup that goes here and it keeps the spring from popping out. But as you would imagine with plastic, it cracks, especially when it's 15 years old. And when this breaks, it can wreak havoc in your engine, it can get jammed up in the timing chain, it can end up in your oil pump, then you lose oil pressure and your engine goes boom boom. So it's important to upgrade this stuff, and we are going with the Emporium stuff. I bought this from the States, and in my opinion this is the best solution to this problem because this is a steel cap. Goes here, the bolt goes through it, and that's it. This is never going to fatigue, crack, or come off in any shape or form. Most aftermarket solutions are pretty much the exact same design as this, just made from metal. But I've seen some horror stories where that metal clips on and then over time it fatigues, it deforms, and it comes off and it makes an even bigger mess. So be careful with what you're using out there. A lot of people won't use this option because this means you have to remove these bolts and mess with the timing of the engine. So if you have to use the clip-on one, I recommend to use the Evolve Automotive one because I know that they're using high quality materials. It's also important to note that when using these cups, you don't use this washer that goes underneath of the bolt because this cup is the same thickness as this washer. The engine is still set at 10 degrees before TDC, and now we can break out the timing tool. Now we need to rotate the cam clockwise and then slide the tool on. Another one here. And now the tool for the intake cam. And that's the cams locked in place. Lube up the inside of the cams. Intake Vanus unit. Note that all 4 Vanus units have an O-ring on the inside, which I replaced. When I took the engine apart, per the repair manual, I put a little screw here. This is to keep the tension for this gear here, because there's an internal spring, and if you just remove it, this is going to spring back and the splines are going to be misaligned. Now I can remove it because in its place I have the special tool from the timing tool kit aligning these splines, and now we can install it. So you got to make sure that these splines are 100% aligned. Per the repair manual, I lightly coated the threads with oil, and it also calls for copper grease underneath of the head of the bolt. Don't want copper grease in my engine, so instead I used ARP fastener assembly lube. These bolts are counterclockwise thread, so to do them up, you go left. Again, no washer underneath of the bolt. Brand new timing chain tensioner. Here's why pretty much everyone opts for a clip-on solution here instead of messing around with these bolts. They are a nightmare to torque. First, as we established, they are counterclockwise threads, so you need a torque wrench that can torque in reverse. And then there's the torque procedure. I can't remember this. First 10 Newton meters, then 20 Newton meters, then 80 Newton meters, and then 200-degree angle. Then you have to loosen it, snug it up to 10 Newton meters. Do the same thing with this one, then crank the engine over to TDC, and then do that torque sequence again. Electric ratchet here. And now 20 Newton meters. And finally 80 Newton meters. Let's see if I can do a 100-degree angle first. Okay, that's 100. That's a lot of torque. Okay, ready? $200. And I'll loosen it. And now you have to torque it to 10 Newton meters. And now we can do the same with this one. Stretch it real good. And I'll snug it up to 10. Now we can remove this tool here. Now we need to set the engine at TDC and then do the final torque. According to the repair manual, this minimizes chain and gear wheel play. So very gingerly. There it is, locked. Okay, final torque, as we already did 10 Newton meters, now we're starting on 20, then 80, and then 200-degree angle. And the repair manual says to start with the intake side. Now you can remove the tools. Exact same process on bank 2. Now I need to put the engine 10 degrees before TDC. The timing tool. the chain tensioner. Exact same procedure for these bolts. First we need to stretch them and then set the engine at TDC. Now back to TDC. Stupid bolts. Oh, everything is gonna hurt tomorrow. How are not all mechanics buffed? Now we can remove the timing tools. Now we need to rotate the engine and then verify that the timing is set correctly. So we're going to do 2 full rotations. It's 1. Coming up to TDC. Okay. Very important, first the timing on bank 2 is checked and these letters here on the cams need to point up. The timing is set correctly when this tool sets flush with the cylinder head. This one is perfect. Double perfect. Per the repair manual, 1 millimeter gap is allowed here, but in this case the timing tools are sitting perfectly flush with the cylinder head. Hopefully you can see from this angle that both timing tools are sitting flush with the cylinder head. Important! Exclamation mark, as the repair manual says. The timing of bank 1 is checked at overlap TDC, so we need to remove the tool, do 1 full rotation, get it to TDC, lock it in place, and then we can check the timing. On bank 1, the markings on the cam here need to point downwards, which they are, as you can't see them, and then the cam lobes need to point downwards at an angle like this. Perfect. And double perfect. The timing of the engine is set correctly. The timing tools are sitting flush with the cylinder head on bank 1 as well. This is how the tool sits on bank 1. All right, let's take it for a spin. That snapping noise that you hear when I'm turning the engine, that's hydro valves and vanos and, you know, stuff happening. Feels great. And that's the timing in time. I double checked the timing, looped up the chain and gears, everything is perfect, so we can continue. New plugs here. At this point, I want to flip over the engine, button up the bottom end, and then we're going to continue with the top. Okay, that wasn't too bad at all. I believe we can do the oil pumps. Indeed, yes, sir. The oil pumps, this is the oil scavenging, aka return oil pump. This is the main pump, all new hardware, new chain. Everything is brand new except for this guide here, which I missed when I was ordering parts. So I'm going to reuse the old one as it looks perfectly fine, and I don't feel like waiting for a few days to get a new one. We gotta mount the guide now. Also the sprocket and the chain. And the nut we can do a bit later. Now we're gonna snug up the bolts, and then we need to set the backlash for this gear here. You can see that we can move the pump slightly, which is how you adjust the backlash for the gear here. It's very, very lightly. I'm gonna put the metal plate here for the magnet. This is the magnetic stand for the dial gauge. So that's now on and firmly in place. This is how you measure the backlash. You move the gear back and forth and then measure it on the dial here. So I'm going to push it all the way that way, then zero it out. The backlash needs to be from 0.06 to 0.08 millimeters. And if you remember, before I took the engine apart, which was, I think, never apart before, I measured this backlash and it was 0.08. So I'm going to aim for that. Right now we have, we're way above spec. That's like 0.013. So now I'm going to take a rubber mallet and then just gently move the pump. That's bang on the money, 0.08. I'm going to snug up the bolts now. I'm going to raise the tool and rotate the engine slightly and check it again. This is where I had problems on Project Raleigh E60M5. I would set the backlash, then rotate the engine and get a completely different reading. So let's see if I have the same issue here. I did a half a turn and we're still at 0.08, which is brilliant. And I'm going to complete the turn. 0.08. Perfect. Now I'm going to apply thread locker on the bolts, remove them one by one. The repair manual does not call for this, but the torque for this is very light and I just want to make sure that these bolts are not going to go anywhere. So medium thread locker, pop it in. Nice. Gotta make sure that this is still within spec. It is, but I'm gonna do one more rotation. With this set properly, now we can remove the tools. A brand new gasket here. Then we have the chain tensioner here. First the base valve, then the spring. Using assembly loop to hold the base thing in place. And now we can pop it in. And I hope I didn't make a mistake and that I can slide in the piston now. Should have done this before I put the pump in, but you live and you learn. The main oil pump. There we go. Gonna do a tiny bit of thread locker here as well. The guide. No torque spec here, we're just going with good and tight. Brand new nut with thread locker. Honestly, this thread locker that I put on new bolts is shit. Like what the it just came off completely. I applied my own heavy thread locker. The one that comes on the bolts simply comes off and doesn't do anything. Thread locker applied on this nut as well. Give it a nice good and twist. Brand new gasket. The repair manual doesn't give a torque speculation here, so we're going to go with 10 Nm because these are M6 bolts. Now we have plumbing for the oil pumps with brand new O-rings on the ends. The bracket. Lube up the O-ring. And that's the installation of the oil pumps done. A clean oil pan, fresh gasket, clean bolts, and originale oil level sensor. Fogging oil for men. Spray the cylinders. Now I need to thoroughly clean the surface and make sure it's oil free, because this is metal on metal gasket. All right, now I'm gonna blow out the oil pan one more time with compressed air. Oil pan going in. We are going to use thread sealer on the bolts. Sealer, not locker. Just a precaution in case oil were to leak down the threads of the bolts. With this stuff, it can't. Gonna very slowly drive them in. The The torque is 10 newton-meters, and I'm going to start from inside to out. The oil level sensation. The drain plugs, 25 newton-meters. This is the one that we repaired, hence a different bolt. Flip it back over. Surprisingly not that difficult to turn it over. All right, let's button up the top end now. Next up, timing chain covers with fresh gaskets and Vanos solenoids that I cleaned thoroughly and then installed brand new O-rings. Clean the surface. The covers are not the same. The one that has two threaded holes here goes in bank 1. The longer screws go into the corners here, and then the shorter ones here. A clean oil filter housing, a new gasket, new cap, new filter, new oil pressure switch, and bolts. Clean the surface. The gasket nicely installed. The oil pressure switch. Lube of the inside. The oil comes later, once the engine is back in the car. And now the vibration dumper. You have to do this after you install the oil filter housing, otherwise you can't get to these bolts with the dumper in place. The tricky bit here is how to lock the crank to torque these bolts, and you can't use this location here because we can damage the dumper, damage this bracket or whatever, and then the timing is not going to be correct after. So there is a special tool that bolts in here, and then it props up against the oil filter housing, and then you can torque it. I don't have it, okay? So let me see what I can figure out. Brand new bolts. These are not reusable. They're stretch bolts. I think I have an idea. This is the crank pulley holder for the M54 engine. Unfortunately, only one hole lines up, but I think that should be enough. Let's see. First, 60 newton-meters. And now 40-degree angle twice. Okay, second round. Well, slap me silly and call me Willie. The rusty pipe saved the day. The pulley. For some reason the torque spec is not listed in the repair manual, but from experience with these bolts, it's typically 22 newton-meters, so I'm gonna go with that. Next up, Bomba de Agua, thermostat, new O-rings and gaskets, lubed up O-ring. Bit of a lubrication here. Silicone spray. Careful with these O-rings. If you pinch them, you're gonna have a leak here. Thermostat installed. New coolant temp. Little pipe connection with a new crush washer. And this white bracket thing for a pipe here that comes on top. New spark plugs. The last big pile of parts for now, we have beautiful aluminum valve covers from NRW Design. They replace stock magnesium valve covers that like to chip, drop paint inside of your engine, cause oil leaks, and are generally very difficult to refinish. So this is a phenomenal upgrade. The link to them is in the description. They also come with new grommets for the bolts. Then we have new spark plug tubes, valve cover gaskets, camshaft position sensors. When it comes to sensors and electrical stuff, you have to use either OE or original stuff. With replicas, the engine will not work properly. The ignition coils, we are going to reuse the old ones because the new ones cost, piano roll please, 209 euros each. And then there's 8 of them. I have 16 of them in stock, so I feel comfortable reusing the old ones. If one of them dies, I can always replace it rather easily. They are not standard ignition coils. They have ion sensing module sensors thingy here in the cap, and after they fire, they send the signal back to ECU, and essentially this replaces NOx sensors, and you end up with 8 individual NOx sensors for each cylinder. Very clever design, fortunately very expensive. I've never seen a valve cover gasket packed like this. Give me my gasket. Make sure that's seated correctly in there. Now I need to lube up the spark plug tubes, just the ends here, lightly. Okay, clean the surface. Drink cafecito. That step is not necessary, by the way. But sure does help. Apply a bit of sealant where the front timing cover meets the cylinder head. Bit of oil here as well. The last round of oil for the camshafts. The one that has a stud and a nut goes here in the back. You're going to evenly tighten the bolts from inside to out in a crisscross pattern. The torque spec is 6 Nm, or you can simply go by hand and you will feel when the bolt bottoms out. Don't over tighten it, and that's it. But because you and I love torque wrench clicks, you're gonna torque it to spec. The fitment of NRW alu valve covers is fantastic, and this is what OE Plus means. Kids, when someone develops a part that fits exactly as the original one, but it's made of much better materials and it's going to function and last a lot longer. Phenomenal design. Hats off, guys. Let's grab the ignition coils. The camshaft position sensors. Lube up the surface. Now, can you guess the torque spec for the camshaft position sensors? Nope. It's 4 Nm and then 45-degree angle. That's right. They had a meeting and someone said, mate, you know those tiny M6 bolts that bolt in the camshaft position sensors? We need to make them interesting. Let's do a 45-degree angle torque. And I'm not going to use a torque gauge because I feel uncomfortable with this. These are very small bolts and it'll be easy to snap them. So I'm just gonna put a marker here and here, and then turn them 45 degrees using my eyes as a measuring device. That feels about right. They could have simply said 10 Nm, 15 Nm, but no. No, 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 no. And then we have these tiny nipples here. I'm probably the only person in the world torquing these bolts to spec. But that's it. We're done. We built the legendary Motorsport S65 engine. Cheers! Prost! Salud! Živeli! This was so much fun. We went from a completely bare block, bolt by bolt, screw by screw, gasket by gasket, torque wrench click by click, and here we are, a fully built engine. I adore this type of work, slow, methodical, precise. I enjoyed every single moment. I really did, and I hope you found it enjoyable as well. From this point on, it should flow pretty quickly. In the next episode, we're going to bolt back everything surrounding the engine, bolt back the transmission, and then back in Project Frankfurt it goes. And then it's first start time. This is the engine for my dream car. This is a pretty special moment right now, and I'm so excited to hear it run for the very first time and drive it as well. And I'm happy that I was able to share all of this with you, and thank you so much for following along. I really, really appreciate it. I wouldn't be able to do this type of rebuild without you watching and following along. So thank you so much. And a special thank you for my Patreons as well. Anyway, if you enjoyed this video, please consider subscribing. I would really appreciate that. Leave a like, comment, whatever. And I'm gonna see you in the next episode. Cheers for now. You know, next time we need to rebuild the S65 engine, I think we're gonna go with a stroker kit. 4.4 liters, baby. And the next engine I want to rebuild is the S85, the V10 in D60 M5, but not Project Raleigh, you better not die.